Newton's third law of motion. All right, the first law, right, said that basically things keep moving the way they're going unless there's a force on them, an unbalanced force. The second law was our math law. Force is proportional to the acceleration, and that proportion is based on mass. And now we're on the third law. And the third law says, right, some people would say for every action, there is a reaction. Okay, and this is also for every force. People talk about how there's an equal but opposite. All right, opposite force. All right, but we got to be careful. These forces are on different things. All right, these guys are on different things. So here is our action-reaction pair. We got a shoe kicking the ball. So we can draw this force, right, from the shoe. It is kicking the ball. All right, fine. Well, the opposite and equal one is there's a force from the ball. Okay, these arrows are on two different things. This arrow is on the ball. This arrow is on the shoe. Okay, the action-reaction forces are on two different things. So here's a chandelier, right, hanging down, and so the chandelier is pulling down on the ceiling, right, and the ceiling is pulling up on the chandelier. Okay, two forces that are the same. They're opposite directions, but they're the same amount, but they're on two different things. So here you go. Dude pushing a refrigerator, right? That's the force from the dude. Okay? Well, the refrigerator pushes back on the guy just the same amount. I know this sounds a little weird, but that's the way it is, all right? You have to understand this is a pair, and they're on two different things. Okay, very important. All right. Look here, you got a water droplet. Okay, so what's with that? What's with the water droplet? Well, technically, the drop is also pulling back up on the earth, and we'll talk about that later. Woohoo. All right, so let's review action-reaction pairs. All right, do they have the same magnitudes, or is one stronger? They have the same magnitudes. We said that. Are in the same direction, perpendicular, opposite, and we said they're opposite direction. All right. Do they act chronologically, one and then the other? Nope, they're at the same time. All right. Do they act on the same object or different objects? This is the big one right here. They are on different objects. And can they cancel each other out? No, not really, right? You can't cancel things out if you're on different objects. That's important. This here is important to understand why they do not cancel. Okay, they're on different objects.